Space-Air Diffusion.
Welcome to the Space-Air Diffusion section of Price's training module. In order to be an effective HVAC designer, you must be able to choose the proper air diffusion devices for your application. And you can't do that without first having a basic knowledge of how air is distributed and moves around in a room. In the upcoming training module, we'll cover the fundamentals of space-air diffusion, including such topics as 1. The occupied zone. 2. Primary air, total air, room air. 3. Throw, drop, and spread. 4. Convection currents. And 5. Returns. The occupied zone. The occupied zone is usually defined as the area within 6 feet of the floor and not within 1 foot of the boundaries of the space, such as walls. As this is the area of occupancy, it is desirable to avoid excessive draft velocities and temperature differences within this space. Primary air, total air, and room air. Primary air is the conditioned supply air being discharged from the diffuser. The primary air is typically moving at high velocities with high turbulence. This action causes induction, which mixes the primary air stream with the room air. Primary air is also referred to as supply air. Total air is the total volume of air in the room which is under the influence of the primary air stream. This is the primary air and the induced room air moving out from the air outlet. The total air is usually considered to be the volume of air within an envelope of 50 feet per minute or higher air velocity. Finally, we come to the medium through which all metabolic heat transfers occur, and thus the most critical factor in controlling human comfort, the room air. The room air consists of all the other air within the space which is not included in the total air package. Proper air distribution conditions the room air and maintains draft velocities and temperatures within comfort levels. Room air movement is created by its gradual induction into the primary air stream, forming the total airstream. It is this constant mixing that provides the mechanisms for heat transfer between the primary and room air. When air movement does not occur, usually as a result of insufficient outlet velocities or poor outlet location, a stagnant layer of room air is formed. The formation of this stagnant layer means that the entire volume of air in the room is not being properly conditioned. It is always desirable to keep the stagnation layer above the occupied zone in cooling mode and as near to the floor as possible when heating from above to reduce the chance of occupant discomfort. Throw, drop, and spread. Throw is the horizontal distance the supply air is projected out from the air outlet. We measure this distance for a specific air velocity. For example, this square cone diffuser has a throw of 8 feet at a terminal velocity of 50 feet per minute. That is to say, the air is still moving at 50 feet per minute at a horizontal distance of 8 feet from the diffuser. Drop is the vertical distance from the diffuser to the bottom of the air jet. When we determine the drop, we also measure this distance for a specific air velocity. For example, the drop of this SCD is 1 foot at a terminal velocity of 50 feet per minute. This means that if we measure the air velocity at a point 1 foot below the diffuser, we will find that it's moving at 50 feet per minute. The temperature of the supply air affects both the throw and drop. Cool air is more dense and tends to fall away from the ceiling, which results in shorter throw distances and greater drop. Warm air is less dense and tends to rise toward the ceiling, which results in longer throw distances and less drop. The spread of an outlet is defined as the divergence of the airstream in a horizontal or vertical plane and is a function of the outlet geometry. The spread has an effect on both the throw and drop. As the spread increases, both drop and throw decrease, and conversely, as the spread decreases, both drop and throw increase. Surface effect. When the primary air is discharged from the air outlet at high velocities, it creates a negative or low pressure zone to form between the air jet and the ceiling. This low pressure area causes the moving air mass to cling to and flow close to the ceiling surface and is called the Coanda effect or surface effect. This effect has a strong influence on the throw and drop distances of the diffuser. Good air distribution design makes use of room surfaces to help keep the supply air outside the occupied zone. Price diffusers are designed to take advantage of the Coanda effect by producing it within the diffuser, helping discharge the air in the proper direction. Temperature, spread, and surface effects are just a few of the factors that affect throw and drop. For more details on these and other factors which affect the performance characteristics of diffusers, refer to the Air Outlet Selection section of the Price Training module. Convection currents. If the room has a wall exposed to the outdoors, there's a chance that you will get convection currents forming along the interior wall. If the exterior is warmer than the interior, a poorly insulated exterior wall might transmit heat to the air in the vicinity, causing it to rise. Conversely, if the exterior is cold, air in the vicinity of the exterior wall will have a tendency to fall as it is cooled. If the convection currents are rising, they can cause the total airstream to separate from the ceiling sooner than expected, which may result in drafts in the occupied zone. When the convection currents are falling down the wall, they can actually combine with the total airstream and give longer than expected throws with drafts in the occupied zone along the floor. Returns. The return air inlet has very little effect on room air diffusion regardless of inlet type or location. However, return air inlets should be located a sufficient distance from the supply outlet so that short-circuiting of supply air does not occur. It may also be desirable to locate the returns in the stagnant zone to remove unwanted warm or cool air. For cooling, a high sidewall or ceiling return will remove warm air from the space. Conclusion. We hope that you've enjoyed this look at space air diffusion. You should now have a better understanding of the mechanics of room air distribution and know that the occupied zone is the zone of occupancy. Primary air is the air discharged from the diffuser. Total air is the volume of air within an envelope of 50 feet per minute or higher. And room air is the medium through which all metabolic heat transfers occur. You should remember to keep the stagnation layer above the occupied zone in cooling mode and below it in heating mode. We've also taken a look at throw and drop, the horizontal and vertical distance the supply air is projected out from the air outlet. We've seen how spread and surface effect can cause the throw and drop to be affected. We've touched on convection currents and how a warmer exterior can cause unexpected drafts in the occupied zone and how a cooler exterior can cause drafts along the floor. Finally, we discussed how returns should be located in stagnant zones and a considerable distance away from the supply outlet to avoid short-circuiting and to promote an effective removal of unwanted air.
Some of these concepts are covered in more detail in Air Outlet Selection. To learn more about space air diffusion, you can also refer to the Price catalog or visit our website at www.price-hvac.com.